In this video, I'm going to show you how to calculate what is called a group mean or weighted mean. And we have data here from five cities. We have the market price per pound of lobster in those five cities. And then we have the pounds of lobsters sold in each city. So the first thing I'm going to do is I'm going to copy the data into Excel. Actually, what I do is I'll right click, paste it as text, and then zoom it out a little bit so you can see. Now, if I take the simple average, it assumes equal weighting for each of these market prices. So what it does is basically it multiplies this times 1, this times 1, this times 1, this times 1, this time 1, adds that up, and then divides by the sum of 1 plus 1 plus 1 plus 1 plus 1. And that is an incorrect average. And the incorrect average is $18.04. We'll copy that into here. The mean price of lobster per pound. The mean lobster price per city is $18.04. Right? Now we want to find the mean price of lobster per pound. And the way we're going to do that is we're going to use something called sum product. What sum product does is it first takes products. It's going to multiply this by the pounds of lobster sold in St. Louis. Then it's going to take this times the pounds of lobster sold in Portland. So it's going to take this times that, this times this, this times this. Then it's going to sum those products. So the way we do this is we highlight the market prices, put a comma, and then we highlight the pounds of lobsters sold in each city. And we get 26,019.6 pounds. Okay. Then the next thing we want to do is we're going to divide this sum product by the sum. Hit enter. And we get something that's kind of close to what the average per city is, 18.30. And the correct average is 18.30. Now, what's going on here? Let's redo this. Let's do a weight of 1, 1, 1, 1, and 1. And I'm going to go ahead and use the ones as the weights in this problem. I highlight the market prices per pound, and then I'm going to highlight the ones. And then I'm going to divide by the sum of these equal weights. And you get the same thing as a simple average. Now, because all these values are kind of close to each other, the average per pound is pretty close to the average per city. But suppose that Boston, because it's on the ocean, people there consume 3,290 pounds. What happens to our average? Well, the average is affected quite a bit by that. Why? Because of the people that eat lobster, right? Most of that consumption is in Boston, which has a low price of 16.4. So that pulls the average down below the average price per city. If I increase this to 32,900, you can see the average is pulled even further down. And it's being pulled down to Boston's market price. But if I increase this to 329,000, now the average price per pound is really close to Boston's market price. And this kind of average is best illustrated by an example of test scores in high schools. Suppose you had a large high school of, say, 1,000 kids, and you had a small high school of, say, 100 kids. If the large high school had an average test score of 50, and the smaller high school of 100 students had a test score of, say, 80, averaging those two by just simply adding the two scores and dividing by 2 would give you an incorrect average of student performance in a town with these two high schools. It would inflate the average up to the smaller school's average. So the best way to handle it would be to take the average score from the large high school, 50, and multiply that by 1,000, and then add to that the average score for the small high school, I think it was 80, multiply that by 100, add those two products up, and then divide by 1,100 students. And you would get an average test score per student rather than per school. And that's it for that problem. Thank you.